Here we are going to look for the representation of a, b, and c as coefficients that will make this linear system consistent. When you say consistent, there are solutions. It could be one or infinitely many solutions, because if we say no solution, that is inconsistent linear system. In order for us to do this, let us try to come up with the row echelon form of the augmented matrix of this given linear system. And let's try to see what should be the correct representation for A, B, and C for this, again, linear system to be consistent. Let's consider this augmented matrix of the given system. 1, 3, 1, A. We will just use A because A is a constant, not a variable here. Then negative 1, negative 2, 1, B. And 3, 7, negative 1, and then C. Let's try to apply row operations that will make this matrix or reduce this matrix into a row echelon form. Since the leading entry of your first row is leading 1, no need to divide or multiply all entries of that row by something else. So we are going to make these two zeros now. We can do that by simply adding first row 1 and row 2 for a new row 2. And multiply negative 3 to row 1 plus row 3 to have a new row 3. So we have it here, 1, 3, 1, and then A for the first row. It was not changed. So let's have the next one here. R1 plus R2, 1 plus negative 1 is 0. Then 3 plus negative 2 is 1. 1 plus 1, 2. So A plus B, you have A plus B. Okay? Next, for the third row, negative 3 times 1 is negative 3 plus 3, 0. So we have achieved this. Okay? Next, negative 3 times 3 is negative 9, plus 7 is negative 2. Then, negative 3 times 1 is negative 3, plus negative 1 is negative 4. And then negative 3 times A is negative 3A plus C. So you have negative 3A plus C. Okay? By the way, our goal here is this last entry here, so please check on that from time to time. Next, since this is already a leading one, let's make this 0. So we could have it here, multiply 2 to row number 2 plus row number 3 to have a new row number 3. That's it. You have 1, 3, 1, A. The next row, 0, 1, 2, A plus B. And then positive 2 times 0 plus 0, 0. Positive 2 times 1 is 2 plus negative 2 is 0. Positive 2 times 2 is positive 4 plus negative 4 is 0. And positive 2 times A is 2A plus minus 3A. So you have negative A. By the way, let's erase this. And then we are going to extend it here a bit farther. And then 2 times B. So you have plus 2B. And you have here plus C finally. So this is already the row echelon form of our augmented matrix for the linear system. And we are going to use this now. Now, when did we say that this is consistent? We can say that it is consistent if this entry here is not other than 0. Because if this is 1, this will make the entire expression without solution, because there can be 0x plus 0y plus 0c is equal to 1. Even if it's negative 1, we can also do that. This is only possible to have a solution if negative A plus 2B plus C is equal to 0. See what will happen to this matrix if that is entirely 0. A, 0, 1, 2, A plus B, 0, 0, 0, 0. Right? That's the entire negative A plus 2B plus C is 0. So if you have this, you have 0 entries for your third row, and you have 2 rows of non-zero entries. And as comparison to your variables, you have x, y, and z, you have 3 variables. So you expect a variable that will be represented by an arbitrary variable, either t or s. And with that, we are sure that we have infinitely many solutions here when this is equal to 0. So this is the result for this linear system to be consistent. It should be negative a plus 2b plus c is equal to 0. Thank you for watching.